Okay, so I see that your number one is correct. The 3 is always in the denominator, or for whatever it is you're doing. Um, these are always in your denominator. Let's see here. And that's a 2 that is there, so this is really 6 to the 3 halves. Okay, so that one's not right. And this is a 2. Whenever there's not a number there, there has to be a 2. So it's 3 to the 3 halves. And 2 to the 7/4. So you might want to make it a little more obvious that those are exponents and not just 2 times 7/4. I know that's what he's looking for. So anyway, the other part of this, let's see here, 4/3. That's 7/6 and 5/4. Okay, so those two need to be changed. Now number 7. So that the denominator is what goes here. So it is the square root of 10 to the first power. You don't need to write the 1 because it either goes there or there, and anything to the first power is just what it is. Okay, and if it's a 2 for a square root, you don't need to put the 2 there. It's understood. Okay, again, here you have the 2, so it is the square root of 7 to the 5th power. Again, the 5 could go there, or you could put it out above it, but I think if you write it the way it is up above, let's rewrite that, and like what we have up here, okay, it would be the square root of 7, and you're going to raise it to the 5th power. Now remember, it can go inside as well, but if we write it the way it is up top, then you put a parentheses around it and put the 5 on the outside. Okay, and then number 11, again, the bottom number is your root, so it's the cubed root of 7 raised to the 5th power. And number 8, again, the cubed root of 4 squared. And again, that's a 2, so it's the square root of 5 to the 5th power. And then the cubed root of 7 to the 2nd power. Okay, so now let's do some of these problems down here at the bottom. Again, let's rewrite it. The 2 is the square root of 49. Now you can put the 1 here or outside. Since it's 1, it doesn't matter. And the square root of 49 is 7. Okay, so you try some of these and then come back to the video and see if you're getting them right. All right, so number 14. Again, the 2 is the root, so it's the square root of 25 raised to the 3rd power. So the square root of 25 is 5 to the 3rd power is 5 times 5 is 25 times 5 is 125. 5 quarters. Cubed root of 27 squared. Cubed root of 27 is 3 times 3 times 3 is 27. So the cubed root of 27 is 3. So 3 squared is 9. Okay, and again we have the cubed root. Cubed root of 216 squared. So 206, cubed root is 216. 6 times 6 is 36. Times 6 is 216. So the cubed root of 216 is 6 squared. So you have your paper, you know that what that is. You have your little table. 4th root of 81. 4th root of 81 cubed. 4th root of 81 is 3. 3 cubed is 27. And now we have the square root of 64 cubed. Square root of 64 is 8. 8 cubed. 8 times 8 is 64. 64 times 8, I have my calculator, so 480 and 32 is 512. Check that to make sure that's right. All right, let's go to the next worksheet. So if you look at your table, you can't take the cubed root of 1125. So what we'll do is we will take the cubed root of 5 times the cubed root of 225. Okay? So you're just breaking these down into something that can work. So you use your calculator, you know 5 goes into 1125, so you divide it and you get 225. And you look on your table and 225 is 15 times 15. But we don't really know for sure. Again, 15 you can't take the cubed root of, so you break it down further. And I'll erase this as we go. And this is cubed root of 5 again. 5 times 45, it's cubed root of 45, is 225. And then we're going to do it again, cubed root of 5, and the cubed root of 5. And 5 is the cubed root of 5 and the cubed root of 9. And whatever your root is, if you have 3 of them, that means it's just 5. Okay? 5 times 5 is 25 times 5 is 125. The cubed root of 125 on your table is 5, so that's why I said 5. And we're left with the cubed root of 9. All right, so you may need scratch paper to try to figure this out, but you got to use your table to figure out that 125 goes into 1125 9 times. Okay, so your answer is 5, I'll just write it out here, 5 cubed root of 9. And you can't take the cubed root of 9. But you need to use that table that you have to figure out which numbers, cubed roots, will go into these numbers that are on this worksheet. All right, so let's do another one kind of like that. I don't have your worksheet to look it up, so I have to use a calculator. All right, so that's a number. Let's go to number 2, the fourth root of 208. So look at your table and look for a fourth root of a number that'll go into 208. Okay, so 16 has a fourth root. It goes into 208 13 times. 16 times 13 is 208. So we have the fourth root of 16 times the fourth root of 13. Fourth root of 16 is 2. 2 times 2 times 2 times 2. 4 times gives you 16. And you're left with the fourth root of 13. So that should be your overall answer. 2 times the fourth root of 13. Okay, again, use your table to help you figure these out. Now you have, on number 3, the cubed root of 108. So I'm going to go through and show you how I'm doing this the long way. If you've already figured it out, then you just move on, fast forward this to something else, to the next one. All right, because I'll go faster after this. So the cubed root of 108, I'm already thinking of cubed numbers that are cubed. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. And 5 cubed is 125. So I'm already past 108. Now, so what I'm looking at is 64 won't go into 108. 27 might, so use your calculator to figure that out. 8 goes into 108, doesn't it? 10, 11 times 8 is 88. 12 times 8 is 96. 13 times 8 is going to be 104, so that's not going to work either. What about 27? 4 times 27 is 28, 8, that's 10, 108. So 27 and 4. All right, so 27 times 4. So the fourth root, the third root of 27 times the third root of 4. Because 4 times 27 is 108. The cubed root of 27 is 3. And I'm left with the cubed root of 4. So that would be my overall answer. So you just have to use your table to help you figure out what will go into 108 and your calculator. All right, so 27 is a cubed root times 4 gives me 108. All right, let's erase that and put that down. We'll go a little faster. Oops. 3 and the cubed root of 4. All right, number 4. Figure out what goes into 396, and it's the square root. All right, so the square root of 396. So 36 times 11 is 396. All I did was look at my square root part of my table. So let me just draw kind of like what the table is you have. So you got the square roots here. You got 2, 3, 4, 5, 6. And all you're doing is going through and taking your calculator. So square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6. And all I did was I went onto my calculator and I took 396 divided by each of these until I got to the point where, as far as I could go. And 36 goes into 396. Okay? So 396 divided by 36 was 11. So that means 36 times 11 is 396. So what we're doing is that the square root of 36 times the square root of 11 is 396. So if we broke it down by a tree, that's what it would look like as well. So just whatever it's going to take for you to figure out quickly using a calculator and your table how to get these answers. So the square root of 36 is 6, and you're left over with the square root of 11. That should be the final answer. Now, I would have a scratch sheet of paper labeled with each of these numbers and how you work them out, because it's hard to do this just in your head and with a calculator, but I mean, that's what I'm doing. All right, cubed root of 896. So now you got to find what cubed root goes into 896. So real quickly, I just did 896 divided by 27 because I can take the cubed root of 27. That didn't work. And then I did 64. Cubed root of 64 is 4. 896 divided by 64 is 14. So the cubed root of 64 times the cubed root of 14. So the cubed root of 64 is 4, and you're left over with the cubed root of 14. I can't take the cubed root of 14. So that would be my final answer. Okay, the square root of 72. All right, so I know that that is the square root of 36 times the square root of 2. I just knew that perfect squares, the biggest perfect square going into 36 is, or 72 is 36. So this answer is 6 square root of 2. All right, now back to number 7. That's the 7th root of 256. So I'll have to think about this because I don't have that table. Okay, so I saw that 2 to the 7th was 128, and 3 to the 7th was like 1,000 something. So I knew 3 didn't work. And if 2 can't get there, I realized, wait a minute, 2 to the 8th would be 128 times 2, which is 256. Okay, so on my 8th root, I saw the number 256. So hopefully you figured out how to use that table really well. So what does that mean? So let's erase this. The 8th root of 256 is 2. So if we break this down, 256, the 7th root, into the 7th root of 256, sorry. And what is that? Sorry, I didn't have my record button on. I wanted to show you what happens if you take the 7th root, if you break it down by the trees. Okay, each of these, the radicals are all still on here. This is still the 7th root of 2 times the 7th root of 2, and so on, okay? All the way over to the 7th root of 2. Well, the root tells you how many of these you have to have. So like, for instance, the square root of 25, you know that that answer is 5. So what I'm trying to say is, the root is a 2, so the square root of 25 breaks down into the square root of 5 times the square root of 5. The root is 2, so if I have 2 of those same radicals, I don't need the radical, and I just combine them as 1. So this has a root of 7, so if I have 7 2's here, 1, 2, 3, 4, 5, 6, 7, there's 7 2's. So I have 7 roots of 2, so that's just a 2. And I have a leftover square root, 7th root of 2, because it takes 8 of these 2's to get 256. So that's how you break those down. You had 1 left over. You needed 1 more to get to the 256. Okay, but you had 7 that went together. So the final answer is 2, 7th root of 2. That was a little bit harder one. All right, so 2, 7 roots of 2. All right. So now we'll do the cubed root of 48. Again, look at your cubed root section, and you'll see that 2 cubed is 8. 8 goes into it. 3 cubed is 27. 27 will not go into 48. 4 cubed is 64. So right there you went past it. So you're going to use the 2 cubed, which is 8. 8 goes into 48. So 8 times 6 is 48. I can take the cubed root of 8, and that's 2. And I have a cubed root of 6 left over. I can't take the cubed root of 6. So that's my simplified version. 2 cubed root of 6. Okay, now the fourth root of 224. So look at your fourth roots. So 2 to the fourth is 16. Does 16 go into 224? And then you look at 3 to the fourth. 3 to the fourth is 81. Does 81 go into 224? So that's how you do this. So use your table to figure that out. And we see that 16 times 14, and these are going to be fourth roots. 16 times 14 is 224. I can take the fourth root of 16 to be 2, and I'm left with the fourth root of 14. There's nothing I can take the fourth root of to simplify that further. 2 times the fourth root of 14. Okay, now let's do the third root of 512. Look at your cubed part. 2 cubed is 8. Does 8 go into 512? And if it does, is there a bigger one? 3 cubed is 27. Does 27 go in? 4 cubed is 64. Does that go into it? You want the biggest one to go into 512. And if you look at your sheet, the cubed root of 512 is 8. So that's an actual number. Now, remember, you can only take the odd roots of a negative value. So I'm quickly looking through these and making sure the ones that are negative have odd roots. So that's odd, that's not even negative. That's odd, that's odd, that's odd. So we're okay. Can't take the even roots of the negatives. Okay, oops, let's go back to, that's 8. Now, 768, what's the cubed root? Remember, if it's negative, your answer is going to be negative. All right, so that's going to be negative, that's negative, that's negative, and that's negative. All right, so now just do the problem and put the negative in front. Cubed root of 768. So that's the cubed root of 64 and the cubed root of 12. So the cubed root of 64 is 4. Cubed root of 12 we can't do. Put your negative in front. So negative 4 times the cubed root of 12. All right, negative 4 times the cubed root of 12. Okay, now the fifth root of 224. And we see that 32 goes into it, what was that? 8 times 240, no, 7 times, 210 and 14, yeah, 7 times. 32 times 7 is 224, and the fifth root of 32 is 2. So 2 fifth roots of 7 is our answer. Let's go ahead and write that down, 2 fifth roots of 7. All right, now we have 216, cubed root of 216. Isn't that 6? 6 times 6 is 36. And 6 times 36 is 36. 18, 2, yeah. So this answer should be negative 6. All right, so negative 6. All right, fourth root of 240. And that's 16 times 15. So the fourth root, and all I did was think on my calculator, 2 to the fourth is 16. So I took 240 divided by 16, and it gave me 15. And I know I can't take the fourth root of 15. So 16 times 15 is 240. Fourth root of 16 is 2. So there's my answer. 2 times the fourth root of 15. All right, number 15. Cubed root of 896. And that's 64 times 14. So it's a cubed root. Cubed root of 64 is 4. Remember, it's negative. And we're left with a cubed root of 14. So that would be our final answer. So negative 4 cubed root of 14. And now cubed root of negative 704. You need to be really good at this without looking at the video. And make sure that you're getting the right answer every single time. Cubed root of 704. And that's 64 times 11. So again, those are cubed roots. Cubed root of 64 is, that's going to be negative 4, and we're left with a cubed root of 11. All right, so negative 4 cubed root of 11. 12, square root, that's a 2 there. Square root of 12, just think about it. That's 4 times 3. Square root of 4 times the square root of 3. So that's 2 square root of 3, just like what we've been doing. All I thought of was 2 squared is 4. 4 goes into 12. All right. And 4th root of 1,053. That's 81 and 13. Oops. And it's the 4th root of each of those. 81 times 13 is 1,053. 4th root of 81 is 3. And we're left with the 4th root of 13. So that whole thing is your answer. 3 times the 4th root of 13. Okay, now 1750, cube root of 1750. 125 and 13, I think. 14. 125 and 14. So these are cubed roots. Cube root of 125 is 5, and you're left with the cube root of 14. All right, so 5 cube root of 14. Seventh root of 1664. Seventh root of 1664. 128 and 13. So seventh root of 128 is 2. Don't forget your negative. Seventh root of 13. So negative 2, seventh root of 13. So this was tough. Hopefully you got through it and you understood it better. I don't have that table. It'd probably be easier with the table. So hopefully you did well.